2 videos of blueprints and the data abstractions, and not 1 line of class code typed yet. That changes now. This video is where we tell Python a brand new type named coordinate exists, and where we learn to keep 2 activities separate, implementing a class and using it. One short statement starts everything. Throughout this lecture, we will be switching our brains between 2 different activities. The first is implementing the class. We write code that tells Python this object type exists, here is the data that represents it, and here are the behaviors it has. Nothing is created at that point. We are only writing the definition. The second activity is using the class. Once the definition exists, we create new objects of that type. We have been doing this half all course long. We have never seen the code that defines the list class, but someone wrote it. Every time we typed L equals the list containing 1 and 2, or L equals the list containing 3, 4, and 5, we were using that class, creating instances we can manipulate in a program to achieve something useful. Today we do both halves. This split should feel familiar because we have already lived it with functions. When we define a function, we tell Python we would like to abstract some code that does something useful, and we write that definition once in an abstract way. We do not run the function at that point, we just define it. Calling the function is the moment something useful happens. Here are the actual parameters. Run with these, give me the output. Classes mirror that split exactly. Defining a class tells Python we are creating an object type that bundles data and behaviors together, and no object exists yet. Creating an instance of the new type is like the call. Now we have an actual object we can manipulate and use. The object we will build is a coordinate in a 2-dimensional plane, simple and pleasantly mathematical. Before writing any code, we think about what a coordinate really is. Take a point in the plane. The point knows how far away it is along the x-axis and how far away it is along the y-axis. That is one instance of a coordinate object. Take a second dot in the same plane. It too knows its distance along each axis. So a reasonable data abstraction is just 2 numbers. 1 for the x distance, 1 for the y distance. Color does not matter here, although a cuter version of this object could carry 1. 2 numbers capture everything. Next, the behaviors. With the data settled, we decide what these coordinate objects can do. Something simple first. Ask the orange point how far away it is along the x-axis or along the y-axis. Those 2 queries will return something like 3 for the x distance and 4 for the y distance. The more interesting behavior. Ask the orange point how far away it is from the green point. That is the Euclidean distance between 2 points, and in a later video, we write the code that computes it. Report x, report y, measure distance to another coordinate. That is the entire interface we want. Here is the beginning of the code that implements the class. 2 lines that tell Python the object type coordinate exists. We are not using the class yet, and no instance is being created. This is pure definition. Reading the header piece by piece. We start with the keyword class in parallel with starting a function definition with the keyword def. Then comes the name of our object type, coordinate. This will literally be the type of the object. Just as we had list and float, we now have coordinate. Then, in parentheses, we name the parent of this class. For now, that parent is the word object. And the 2 lectures from now, we will see what happens when we put something else there. Writing object here tells Python that anything a generic Python object can do, our object can do too. Something as basic as being created in memory and assigned to a variable so that the variable gives us a handle on the object. Every Python object can do that, and now a coordinate can as well. Underneath the header sits a docstring describing in plain English what this class is, a coordinate made up of an x and y value. So far, Python knows a data type called coordinate exists. What goes in the body of the class is attributes, and attributes come in exactly the two flavors that make up any object: the data that represents it and the procedures, also called functions, also called behaviors, that it can perform. For our coordinate, the data is two numbers. The behaviors are functions, but written in a special way that tells Python they can only run on an object of type coordinate. That restriction makes sense. Finding the distance between two integers is just subtraction, no special behavior needed. And the distance between two dictionaries has no meaning at all. The distance behavior we sketched belongs to coordinates alone. Functions restricted to one type like this get a special name, methods. From the next lecture on, that is the only word we will use for them. The whole video comes down to one mental separation. Implementing a class and using a class are different activities, the same split as defining a function versus calling it. Implementation decides three things: the name of the type, the data that abstracts it, and the behaviors it offers. For our coordinate, the name is coordinate, the data is two numbers, and the behaviors are report x, report y, and measure the distance to another coordinate. The header line brings the type into existence, and through the word object in parentheses, hands it everything a generic Python object can already do. The body will hold the attributes, and its first entry is the special method that builds every instance. Done the init next video. To practice what you just learned, this course has free exercises and AI graded feedback on ludium.ai. The link is in the description.